All right, this brings us to our final section in our final video. Here we're going to discuss matter and energy, particularly the energy part. We just kind of spent the beginning of this chapter talking about all the matter. Remember, matter is the amount of stuff in anything that has stuff and takes up space, or anything that has mass and has a volume. Energy is going to be the other side of everything. So energy we're going to describe as our ability to do work or cause a change. We just talked about two different changes, physical and chemical. In order to go through either one of those changes, we need energy in order to do so. There are different types of energy. The first one we will be talking about is thermal energy, but before we define thermal energy, we have to define temperature. Temperature is a term you should all be familiar with by this point, but you might not know what actually means. Temperature is an average, so it is a mean. I am adding everything up and I'm dividing it by how much there is. It is an average. What am I adding up? Well, I'm adding up the motion of all my particles. All these little particles inside this substance, whether they're molecules or they're individual atoms, they are constantly moving. If they are moving slow, then my random motion is going to be low, and therefore I'm going to have a low average, and therefore I will have a low temperature. If my movement is fast, then I will have a lot more motion going on, therefore my average will go up, and I will have a hot temperature. You can think of this as in video games a lot of times when you have freeze rays or something, things slow down. So when you cool things off, you are slowing these particles down. Sometimes in video games, you step in lava or something and your character runs around all aimlessly and fast. So when you heat things up, when you put on a lot of temperature or a hot temperature, you speed up those particles and they move faster. This is going to lead us into thermal energy. Thermal energy is a total. It is not the average. The average is temperature. Thermal energy is the total energy of all the particles in an object. In thermal energy at least, it is going to always flow from warm matter to colder matter. So if I put an ice cube in my water, it's a little awkward to think of it this way at first, but you get used to it. I put my ice cube in water. My water is a liquid that's obviously at a higher temperature than the ice cube. What's going to happen is the thermal energy, the motion of the particles in the water is going to be starting to transfer into the ice cube. So the water is really going to be heating up the ice cube, so to speak. The ice cube will therefore melt. Or the water is transferring thermal energy to the ice cube and speeding up the particles in there because they're getting hotter, because the water is a warmer environment. Therefore, your ice will melt, and in return, it cools off your drink because all that energy that is in your water is being thrown into this ice cube. That is just a transfer of thermal energy. We have two different types of energy transfers that you're going to really pay attention to. We are going to lump these in with your chemical changes. These again, a chemical change we could call a chemical reaction. So here we have endothermic reactions and we have exothermic reactions. Endothermic reactions are going to draw in thermal energy from your system. So basically things get cooler as you combine them. For example, here we have sodium polyacrylate mixed with water. It is a endothermic reaction, meaning it is taking thermal energy from its environment and absorbing it. On the reverse, you have exothermic reactions, which is a release of energy. Over here, you have aluminum and bromine mixing together, and you'll see that we are releasing a lot of heat. Another way you can look at the prefixes, endo as in enter, exo as in exit. Endo, it takes in energy. Exo, it releases energy or exits energy. There are different forms of energy. There are really only two, but our book is going to get into more because they are a little more specific. But the two types of energy that we really associate with is kinetic and potential. Our book is going to discuss the other ones as well, and I'm going to go briefly into them in this video. But first off, we will look at kinetic energy. Kinetic energy is energy in motion. So if I had to ask you, is thermal energy kinetic energy? You should be saying yes, because, well, thermal energy is movement of particles. So particles are in motion. Anytime things are in motion, we give them, or we state that they have a kinetic energy. The other type of energy is potential. Potential energy is based off of position, and it has the potential to do work. It might not necessarily be doing work, but it could. An easy way to look at that is through height. If you just lift something up high, it has the potential to fall. When it falls, it turns into kinetic energy. The higher you lift it, the more it can fall. Our little cart here, you can see as time goes on, it starts at the top. We have high potential energy. As it goes down, that potential energy is being transferred into kinetic energy here, and our kinetic energy increases as its movement increases. But if it was just sitting up here not moving, it could fall. It has the potential to do that, but it's not right now, so we call that potential energy. It is based off of position. Our next type of energy is chemical energy. Chemical energy is what's stored in these chemical bonds between our elements that make up our compounds and molecules. A good example of chemical energy is the glucose molecules that are inside plants. So through photosynthesis, your plant makes its own food into glucose, and it stores the energy it needs to survive and be a living thing. In these molecules. That is chemical energy. You, in return, will eventually eat these, and you will get chemical energy through eating them, because it is a stored energy that is in their bonds. Your body will break apart these bonds, break apart that sugar, and provide energy for you to do other things. A lot of times, as it is stored, we consider that potential. But as you break it apart and start moving around, you burn your calories, you burn your energy. That is the kinetic energy aspect of it. Next is a very large spectrum, which is electromagnetic energy. We will go into greater detail into this later, but electromagnetic energy is just a different name for light. Be careful though, because you don't always see all types of light. Here we have visible light, which you can see. I mean, thus the name visible. These are all your different colors, your Roy G. Biv spectrum. You have infrared light, which you can't see, but a lot of cameras can. UV light, which you, when you go to the beach and sunbathe, you probably get sunburnt. That's caused by your UV rays. Radio waves are also considered electromagnetic energy. It is a type of light. That's how your radio is going to receive signals, and you can use your walkie-talkies to throw radio waves across places. On the higher end, gamma radiation, or gamma rays, are going to be a type of light. We'll talk more about that when we get into radiation. And you probably are also familiar with microwaves, whether it is the device you use to heat your food. Really all it does is jiggle water molecules, so it vibrates those water molecules and provides a kinetic energy to them. This is also, however, how your cell phones communicate. So your cell phones do transmit through microwaves, all of which fall on your spectrum for visible light. Our next one is electrical energy. Electrical energy is just a flow of electrons. You can, and many scientists do, argue that this is a type of matter. I mean, electrons are matter. They have mass, they take up space. But a lot of times feeding electrons into different systems will give the ability to change, so we can argue that it's also energy. Again, we talked a little bit about electrolysis as an agent for chemical changes, and you can think of batteries as a way to store electrical energy. Next we want to get into is transfer of energy. Again, just like matter, energy is conserved, so you cannot create or destroy it, but burning a candle could transfer the energy within the chemical bonds of whatever your wick is made out of. It varies depending on candle and wax, into different types of energy, such as thermal energy, which you'll experience as a release of heat, sound, you'll experience maybe crackling from fires and different light, obviously, electromagnetic. You can think about pushing your bike up a hill. Again, that relationship between kinetic energy and potential energy. The more you push up the hill, the higher it gets, so therefore the potential it has to fall increases. So you're taking kinetic energy and turning it into potential energy. And if you go vice versa, that would be like the little card at the beginning. Photosynthesis also is going to take electromagnetic energy from the sunlight, because your plants need sun, and turn that into the chemical energy that it stores.